Hi, my name is Mohammed El Khatib, and today I will be presenting the paper titled Implementation and Benchmarking of a New Generator Dynamic Model. First, for some background, accurate stability simulations and accurate models are crucial for reliable and secure operation of transmission systems and proper planning. This paper presents the implementation and benchmarking of a new model called GENQEC. This model is implemented and benchmarked in 4 of the widely used commercial power system analysis tools. Dynamic simulations has been performed on simplified single machine infinite bus and also on a large real system. These simulations indicated that the new model is responding properly as expected and exhibited improved static and dynamic generator performance as compared to other widely available generator models. Model benchmarking shows that the new model produces very close responses in all 4 software platforms that were tested as part of this work. And also validation of the model simulations against field measurements has been performed. And it showed that the new model generates responses that are very close to the field test results. So the first half, the top half of this slide shows the performance of the GenQEC model in a single machine infinite bus case, where we have a 13.8 kV, 81.2 MVA hydro turbine generator. That single machine infinite bus was tested using GenQEC, GenTPJ, GenSal, and also field measurements. So the results on the top here shows the performance of the GenQEC against GenSal, GenTPJ, and field measurements for a 3% step change at the AVR set point. As can we see here from the results, the GenQEC performance matches quite well with the field measurements, especially when it comes to the field current, where the GenTPJ model kind of deviate from the actual field current that was measured in the field, but the GenQEC model matches quite well. In the second half of the slide, in the bottom results, we show here the performance of the GenQEC model when it was applied to a very large case, the WAC planning case. In this case, we had 1,820 synchronous machines, and the GenQEC model was applied across all of these machines. And then a variety of contingencies were tested in the WAC planning case using PSSE. These simulations showed the usability of the GenQEC model and that it is stable and suitable to be used for large transmission planning studies. So the GenQEC model was implemented in PSSE, in Power World Simulator, in DSA tools, TSAT, and also in PSLF. Benchmarking tests used the same single machine infinite bus system in the different softwares, and different simulation tests were performed in the different softwares. So the paper present the different tests that were implemented to validate the GenQEC model across the different software platforms. In this slide, we show two of those tests, the 5% step change at the AVR, and also voltage and frequency oscillation being played back and at the infinite bus. So as can be seen in this slide, the responses across the different softwares are almost exactly the same, which shows that the model has been implemented accurately across the different software platforms. In conclusion, the WAC approved new generator model GenQEC has been implemented, tested, and benchmarked in 4 widely used commercial power system analysis software packages. The benchmarking tests show close responses across the 4 tested software platforms. Simulations performed on the WAC interconnection indicate that GenQEC performs properly, stably, and robustly. The model validation indicates that the simulated responses of the GenQEC closely matched the field measurements, and therefore the new GenQEC model is appropriate and accurate for transmission planning and operation studies.